So this video is going to explore what happens when the compounding periods vary, and we're looking at creating recurrence relation for compound interest. So to do this, we first of all need to look at the definition of what is a nominal interest rate and then what is compounding period. So a nominal rate, this is the annual rate that is quoted on a loan or investment. So what that means is this is basically when I say to you compounded at 3.2% per annum. That is what the nominal interest rate is. It is 3.2%. Now, all the questions we've been looking at so far have a compounding rate that is yearly, so we just compound them every year. Now, what can happen is compounding periods can vary. So you can have a nominal rate of 3.2%, but it could compound quarterly or biannually, weekly, monthly. You get the idea. There's a few different ways this can happen. So compound period then is the time period. And it is the time period after which the compound interest is calculated and paid. So just for assumptions and things like that, there are 12 equal months in every year, so we just assume they're equal. We appreciate they do have some different values for number of days and things like that, but we just say monthly is this. Quarters, there are 4 quarters in every year, and each quarter is equal to 3 months. We say there are 26 fortnights in a year, and 52 weeks in a year, and 365 days. We ignore the existence of leap years. So they're the kind of generic assumptions that we need to make. So let's have a look at a question and how this affects our recurrence relations, because that's what we're interested in. So we're told Diego will invest $7,500 and will earn compound interest at a nominal rate of 9.6% per annum. Let AN be the balance of the investment after n compounding period. So that is different to what AN has represented before. AN before represented how much the investment was worth after n number of years. So what we have to be careful of is the value of AN is slightly different. So when I'm compounding period is yearly, AN will represent years. So it would be 1 year, 2 years, A3 would be 3 years. But when we change that to quarters or months, for example, if it was months, A1 would be after 1 month, A2 would be after 2 months. So you would have to go all the way to A12 to see what would happen after a year. So just be aware that when we change our compounding period, the value that AN takes changes, what that represents. So to construct a recurrence relation looking at yearly, this is exactly as we've done before. So we've got our general form. We always know that A0 will equal to P, and our AN plus 1 is going to be equal to our AN times 1 plus I. So for this first one, A0 is going to be equal to 7,500, and our recurrence form, AN plus 1, is going to be equal to AN times 1 plus I. And remember, I is the value converted to a decimal. So this interest rate up here would be I equals 0.096. So it's 1 plus 0.096, which we can then write in a more simplified version as 1.096 lots of AN. Okay, B, quarters. So when we change the compounding period, what we need to do is say, well, this is a nominal rate. So this rate actually represents the full year value. If we're only compounding in quarters, then what we need to do is take this full year value and divide it into 4, because there are 4 quarters in a year. So what I do is I take my interest rate of 0.096 and I divide it by 4 to find out what each quarter is going to be worth. So in this case, let's just grab our calculator. We are going to be doing 0.096 and divide it by 4. So we get I is the new value, just put that up one more time, of 0.024. Now crucially, we must do this before we add it to the 1 in our recursive form. So we divide the interest rate by 4 because it's quarters, and then we go back to creating our recursive form. So we still have the same principle, that has not changed, that's 7,500. But now, to work out what is happening, we have an times 1 plus 0.024, which means we have the recursive form of 1.024 lots of an. Okay, the final one, monthly. So again, this is a nominal rate of 9.6%. So what we need to do this time is actually divide our 9.6% by 12, because we're splitting it into 12 equal interest rates over the year. So we're going to get I equals 0.096 divided by 12. So 0.096 divided by 12 is going to be, so that represents there, that's 8 times 10 to the negative 3, which means that I'm going to have, so 8 times 10 to the negative 3, which means I have 0.008. I need to divide by 8. Divide 8 by 10 3 times, which means my decimal point moves 3 places to the left. So that is now my new interest rate. I then say, right, my recursive form, well, let's always start with a 0, so that has not changed again, that's still 7,500. And my recursive form is going to be an times 1 plus this new interest rate, 0.008. So I get an plus 1 equals 1.008 an. And they're the 3 versions using the same nominal rate of 9.6%, but for yearly, quarterly and monthly.